All right, so we are going to be figuring out a couple things here. We need to figure out the total current. So the I total, put up here. And we need to figure out voltage at R1, voltage at R2, and voltage at R3. So these are the answers I need for this. Now, some things are given, like the voltage is 6 volts. See that right over here? So that's pretty easy. And then the resistance total I can get by adding all of these up. So we've got 100 plus 100 plus 450. So R total equals R1 plus R2 plus R3, which is 100 plus 100 plus 450, which is going to give us an R total of 4, 5, 6, 50. So that's the R total. Once we have the R total, we can figure out the current total, because current total, I total equals V total divided by R total. So I total is going to equal 6 volts divided by 650 ohms, which is going to equal, if I put it in my handy dandy calculator, 6 divided by 650 is going to equal, I'll just put it up here, the answer, 0.0092 amps. That's what I'm going to round it to. But to do my calculations, I am going to do a memory save on that. Now, each of these is going to use basically the same formula, which is we're looking for the voltage. So voltage R equals, so the voltage at each individual R is going to equal I total times that R. So the voltage at R1 is going to equal the current, which we're abbreviating as 0.0092 times R1, which is 100 ohms. So if I put that in the calculator, I multiply this by 100, I am going to get 0.925, 0.925 I'm going to say. Or maybe 923, you know, it's in the ballpark. Say 923, that's fine. Volts, the second one is exactly the same, so I don't have to do the math for that. It's 0.923 volts again. And then voltage at R3 equals 0.0092 volts times 450 ohms, which gives me, if we go in here and do this, clear, I'm going to use memory recall to get my current back, and then times 450, which gives me, I'm going to say 4.15 volts. And now, if I add these three numbers together, I should get 6. So let's see, plus 0.923 plus not 9, 0.923. And yeah, it's extremely close to 6, and probably only cut off because I rounded these two figures. This is good. These are the answers you would need. And we can move on. So moving on to our next slide, The current in this circuit is 0.2. Now keep in mind, I changed mine. You guys had it as 0.2, but it's got to be 0.02 or this doesn't work. So keep that in mind. And we are looking for R3, and then our voltage drops. So we have the current, so that's amps, right? Because that's current. And I know it's in the next line, and we have the voltage over here, so we have that. So we are looking for R3, and we are looking for, V at R1, V at R2, and V at R3. So we're looking for those things. That's what's required for this one. So to figure out, any of these, we can figure out some of these voltage drops right now, but we really need to figure out what R3 is first. So to do that, I'm going to find the total resistance. And to find the total resistance, R total equals V total over I total, which is 6 divided by 0.02 amps. So I'm going to take my calculator out, 6 divided by 0.02 for amps, and then I have an R total of 300 ohms. Okay, so now R3 is going to be what's left over after you add R1 and R2 up. So like we've got 300 ohms here is equal to 150 plus 25 plus X, which would be R3. So if I subtract 150 and 25 from both sides, I end up with X on this side, and then I end up with 125 on this side. So R3 is 125 ohms. Once I have this figure in, I can continue with the rest, because we actually could have done this one and this one with the information we already had. So I'm going to do this a little more quickly than I did on the other one, but basically following Ohm's law, voltage at R anything, like Rn, equals I total times, the resistor. So V at R1, V at R2, and V at R3 is equal to the current, which we said was 0.02 amps, and it just straight the way down there, and that will be times 150 ohms times 25 ohms and times 125 ohms. And let's do that. So I'm going to do 6 divided by 0.02. Oh no, I don't even need to do that. I got 0.02s already, so I do 0.02 times 150, which is going to give us 3 volts. And then I'm going to do 20.02 times 25, which is gotta erase this here, 0.5 volts. And then I'm going to do the 0.02 times 125 for the last one, which is going to give me 2.5 volts. And when you add these together, 3 plus 0.5 plus 2.5, you do in fact get 6 volts. So that all works. All right, so moving on to the last one. This one figures out the voltage and then the voltage at each resistor. So we're going to need V total equals, and then VR1, VR2, and VR3. Okay, so first thing we got to do is figure out R total. R total equals R1 plus R2 plus R3. And R total equals, equals, 3 plus 1 plus 2. So R total equals 6 ohms. So that's the R total. So to get the voltage total, that equals R total times I total, which voltage total equals 6 ohms times 0.25 amps. So voltage total equals, I believe that's going to be 1.5. So 6 times 0.25 is 1.5 volts. So that is our voltage total. Volts. Okay, and then we just got to find the voltage drops. So that's the same deal. Voltage at any resistor equals I total times that resistor. So VR1, VR2, and VR3 equal 0.25 amps all the way down times 3 ohms times 1 ohm and times 2 ohms. Okay, here we go. So I'm just going to start doing this in the calculator as you can see. 0.25 times 3 is going to be 0.75 volts. 0.25 times 1 equals 0.25 volts, go figure. And then 0.25 times 2 is going to be 0.5 volts. And if you do add these up, you will in fact get 1.5 volts, proving Kirchhoff's law. Okay, so I hope this was all helpful. Good luck.